Okay, this is part 2, looking at section 3.3 and grouped/bin data and measures of center, measures of dispersion, and we just got done talking about this concept of a weighted mean and how it's calculated, and now we're going to do an example with grade point average, or GPA. So Marissa has completed her second semester of college. She earned a B in her 5-hour calculus class. She earned an A in her 3-hour social work class, an A in her 4-hour biology class, a C in her 3-hour literature class. So we assume this is a standard scale: 4 points for an A, 3 points for a B, 2 points for a C. We want to determine her GPA. So what we're going to do is we're going to take the so up here we're going to take the weight and times it by that actual value. So the first one we have is a B, so that has a weight of 3 at 5 credits. Okay, plus the next one was an A at 3 credits. Then the next one is an A, so 4 points at 4 hours. Let's see, so 4 hours or 4 credits. And then the last one was a C, which is a weight of 2 in a 3-hour class. Okay, and then we're going to divide all of this by the sum of the weights. So 5 plus 3 plus 4 plus 3. And I think I said that backwards in the beginning. So the weights are going to be the credit hours, and so the weight are going to be the credit hours, and the values are the grades. So we took a B times 5 credits, an A times 3 credits, an A times 4 credits, and a C times 3 credits, and divided it by 5 plus 3 plus 4 plus 3 credits. So when we add all of this up and do the division, we get 49 out of 15, which is approximately 3.27 GPA. Okay, so that's the idea of a weighted mean. We're not going to go very deep into these, but just know that it exists and how to do some simple calculations on those. Okay, now the last one is approximating the standard deviation for group data. Okay, it's very similar from what we did when we were finding the mean, but we actually, in this case, we have to use the formula for a standard deviation, but we're going to use kind of the same process or the same idea because we don't have access to the original data. So it's an approximation. So if it's the population standard deviation, we're going to take the sum of the deviations, again, where x sub I is the midpoint. So the sum of the deviations squared times it by the frequency. So say the midpoint is 15 and the mean is 20, then that deviation would be -5, and we would do -5 squared, which is 25, and then if there were 100 values or data points in that class, then we would take 25 times 100, and then we would divide it by the sum of all of the frequencies when we got through all of the classes. So the only thing that changes with the sample is we subtract 1 in the denominator after adding up all of the total frequencies. So let's do an example of this. And I will show you this by hand. It's going to get a little grisly, but just so you can see. But no, StatCrunch is going to be a valuable resource, and you can use StatCrunch. I don't expect all this to be done by hand. Just want you to see the kind of mechanics behind it. So first thing we're going to do is we're going to have our class. And this is going to get long. So brace for impact. So first class is 0 to 19,999. Okay, then we're going to have the midpoint, which is our x sub I. Okay, and then once we've got the midpoint, we are going to look at the frequency in each class there. So we'll have the frequency, and then we're going to have the deviations. So we'll have that midpoint minus the mean, and then finally we're going to take the midpoint minus the mean squared, times it by the frequency in that class. So this is going to get big, and it's going to get big in a hurry. So the midpoint of the first one is 10,000. The frequency is 344, and then I'm gonna need some more space here. So I'm just gonna squeeze it in over here. So we'll take the midpoint, 10,000, minus the mean, and remember the mean was 23,221. That was from the very first problem. Okay, so this was equal to negative 13,221. So that's the deviation in the first class. Okay, so then the next class was from 20,000 to 39,999. The midpoint there was 30,000. And then we had a frequency of 98. So you take 30,000 minus the mean, 23,221. Okay, and that got us to 6,779. Okay, and then our next class was from 40,000 to 59,999. So then we'll have a midpoint of 50,000, 52, and we take 50,000 minus 23,221. Okay, that's going to be 26,779. So we're basically going to be adding 20,000 to all of these here now. And you'll notice that I have not done all of the deviations squared times the frequencies yet. I'll get to that in a moment. Okay. So then in our next class was from 60,000 to 79,999. Okay, the midpoint here is 70,000. The frequency was 19. So then the deviation would be 70,000 minus our mean, 46,779. Then their next class was 80,000 to 99,999. So 90,000 would be your mean. 13 would be our frequency. And 66,779 is the deviation. We're getting closer. Hopefully you can have a little bit more gratitude for StatCrunch now. Okay. So then this one's 100,000 to 119,999. Our midpoint here is 110,000. And that was a frequency of 6. So our deviation, 110,000 minus the 23,221 is 86,779. And then lastly, 120,000 to 149,900. Excuse me, that would be 139,900. So midpoint here would be 130,000. We had 2 in this frequency, so this would be 106,779. Now, when I take the deviation, square it, and times it by the frequency. So I would take, for the first one, I'd take negative 13,221, square that value, and then times it by 344. And it's big. 6.01 times 10 to the 10th. Okay, then the next one, I would take 6779 squared, and then times that by 98, and I get 4.37 times 10 to the 9th. Okay, and the next one is 3.73 times 10 to the 10th. 4.16 times 10 to the 10th. 5.80 times 10 to the 10th. 4.52 times 10 to the 10th. And lastly, 2.28 times 10 to the 10th. So when you add all of this up, this is approximately 2.6937 times 10 to the 11th power. And that's our frequency. That's our deviation squared times the frequency. So then our standard deviation is the square root of that grisly thing, 2.6937 times 10 to the 11th, and then divide it by our total frequency. So if you add up all the frequencies, it's 534, and then minus 1, and this is 22,484.5. Okay, so that huge mess is how we get standard deviation by hand. So again, with StatCrunch, not nearly as difficult. So I've got all of my data right here. So what you do, again, you go to Stat, Summary Stats, Grouped. Then our bins are, in this case, they're in the savings. That's our groups. And then the counts are the frequency, and those are in the savings frequency column. We want to do consecutive lower limits to make sure the standard deviation is selected. We'll compute, and you can see there 22,484.5. Oh, I just wrote it down wrong on my paper here, or my iPad. So this will be 484.5. Okay, but hopefully you can see StatCrunch is going to be a tremendous help. I don't expect you to do all that out by hand, but that just gives you a little bit of idea of the mechanics behind it, how it works. So these problems can get a little tedious, they can get a little long, so you don't have many in this section, but that's a look at section 3.3. If you got any questions, let me know.